Consider this circuit where the value of R1 is given as 14 ohms, R2 is given as 4 ohms, this R2 is also 4 ohms, and R1 is 14. So we have to find the potential difference between A and B. For that, I think let's just find the equivalent resistance and hence the current. So because if we get the current in this uh, branch, we can easily use the, what do you call it as, we can easily travel from A to B and get the potential difference between them, right? So for the equivalent resistance, these two are in series. So their equivalent will be 4 plus 20, which is 24 ohms. And then the equivalent circuit is going to look like this. Right, 1, 2, and 3. So this is 24. This is 4 and this is 14. So this 4, 14, and 24 are all in parallel, right? So they are all in parallel. It means that we can replace it with another equivalent resistance. Let's call it R. This is already 14 and this is 25. So this value of R we can find using mathematically by the formula that 1 over R is 1 over 14 plus 1 over 4 plus 1 over 24. So I think that's where my calculator comes in. So let me just do that. 1 divided by 14 plus 1 divided by 4 plus 1 divided by 24. And remember to take the reciprocal of that value as well. So resistance is coming around 2.75 ohms up to 2 decimal places. And what is the current now? Current we can easily find, right? Because current will be in this direction. So the current is voltage over the net resistance, and now these two are in series, so that will be 2.75 plus 14. So if we add 14 to it, and 25 over this value comes out as 1.49 amperes. This is the required current, but we don't need current, we need the potential difference. So we can easily get the potential difference between A and B. We travel from B to A like this. So if we travel from B to A, then we'll get VA minus VB. Since the final point is A and initial is B, we are traveling from positive to negative over here, so that's negative, and the current is directed over here, so it is over here, so we are traveling opposite to the current. That will be plus IR, where I is 1.49 and R is 14 over here. So we multiply this with 14 and subtract 25 to get negative 4.11. So negative 4.11 volt is the potential difference between VA minus VB. So A is at a lower potential. Okay, now I'm not sure whether they are interested in the magnitude. So if they're interested in the magnitude, just get rid of this negative sign. And in last part, part B, they are interested in the current in 20 ohm resistor. Where is 20 ohm resistor? Let me just clear this up. So 20 ohm resistor will be over here. So let's say the current over here is I. And now we use the loop rule in this bigger loop. So if we travel like this, we are going along the current. So we will have a negative of IR, where I is negative 1 point, is negative sign. With negative sign we have 1.49 times 14. Positive is battery, and then we are going along the current for these two as well. So that's minus of I times net resistance is R2 plus 20, right? And what is R2 plus 20 here? 24. So that's 24, and that is equal to 0. So this will become, I think, 25 minus this value we have already found as 4.11. This was negative 25 plus this. So this is 25 minus was opposite sign, and that is equal to 24I. And if we divide both sides by 24, we'll get the value of I as 0.17 up to 1 decimal place. So this is the required current which is flowing through the 20 ohm resistor. Thank you.